welcome back. We're in lesson 10 today. And we're going to talk about some really cool stuff. The first thing we're going to talk about is really quick, division by zero. The operation of division is the inverse of the operation of multiplication. We understand that. And we know that if we say 6 divided by 3, if my pen would actually work, we get 2. Because we know that 3 times 2 is 6, right? So we know the inverse operations of those. And because of that, we know that 6 divided by 2 is 3. Because they're the inverse of one another. We will now use the same thought process and try to decide what the result will be if we divide a non-zero number by 0. So if we say, let's say 6 divided by 0, what do we get? If we divide by 0, technically, if we divide by 0, we're not really dividing, right? So 6 divided by 0 really has no meaning. So what we say when we divide a number by 0 is that that is undefined. Because you're not dividing anything. It stays 6. So there's an undefined operation of some type going on. You can't divide by 0. So indeterminate is something that we use to describe a situation where 0 is divided by 0, right? Because that's just weird. I mean, if you have nothing, right? You have nothing. My pen is just jumping all over the place. It's making me a little distracted. If you have nothing and you don't divide it, what are you doing? You're kind of wasting your time. So it's indeterminate. Let's be an R in here. Indeterminate is what you have when you have 0 divided by 0. Undefined is what you have when you have 6 divided by 0, or any number, and you divide it by 0. Basically, you say, I just have this number, and I'm not going to divide it. Okay, well, I don't know what you're doing. You're undefined. Well, I have nothing, and I'm not going to divide my nothing. Okay, I think you're a special kind of crazy, so we're going to say you're indeterminate. That's basically what you're saying. Now, if you have nothing, and you want to divide nothing by 2, then both of you get nothing. You can divide 0 by a number. The answer is going to be 0. Pretty straightforward. But if you divide by 0, which is kind of stupid, you get undefined, and you try to divide nothing by nothing, that's just even more crazy, and we call that indeterminate. Remember those. These will be on quizzes and tests as you go forward. So write those down. A number divided by 0 is undefined, and 0 divided by 0 is indeterminate. All right. Moving forward, I'm going to clear the page. Now we're going to talk about the exchange of factors in multiplication. Basically just restating the commutative property of multiplication, that it doesn't matter what order you multiply numbers in, it's going to be the same product. So for instance, if we have 3 times 4, that equals 12. If we have 4 times 3, that equals 12 as well. Okay, pretty straightforward. A commutative property for multiplication, that means that when you commute the numbers around, commute means to travel. When you move the numbers around, that's still the same answer. No biggie. So we're going to practice that. Let's do 10.2. I don't know why I put an equal sign there. That's kind of silly. So we're told to find the product for a negative 4. And remember I told you about those parentheses. Now we're starting to use them. Times negative 3 times negative 6. That's supposed to be a 6. Times negative 2. Okay? That's our problem. And you can see that we're not using the little dot or the X's. We're just using parentheses. So negative 4 times 3, that's going to be negative 12. Negative 6 times a negative 12, that's going to be a positive 72. But you know what? I like to do it a different way. Negative 6 times negative 2, that's going to be a positive 12, right? Negative 12 times positive 12. We know that multiplication table. It's 144, but the signs are different, so it's going to be negative, right? All right, so if we did this in a different order, let's say we did negative 6 times negative 2 times 3 times negative 4. What do we get? The same thing. All right, we get positive 12 times negative 12. Same answer, negative 144, right? Get the same thing. This is 10.3. 10.4, we tried in another order. If we get negative 6 times negative 4, same numbers, times 3 times negative 2. First, I want to point out that, we have 3 negatives in all of these, so the answer should be negative in all of them, right? Okay. So negative 6 times negative 4, that's going to be a positive 24. I don't know why I wrote the positive sign. You understand that? And that's going to be times a negative 6. 24 times negative 6 is negative 144. All right, so we can see that it doesn't matter what order. The order doesn't matter. With the commutative property of multiplication, the result, the product, is going to be the same. And we know that when we multiply numbers, the answer is called a product, right? Right, okay. So the resulting product will always be the same regardless of what order we multiply in. That should be a given for us. All right, now we get to the fun part. I'm fixing to clear the page, so if you need to pause and take notes, do so now. Now we're going to talk about conversions of area. You know how we've been using unit multipliers to convert lengths from one unit to another unit? Well, now we're going to get to do that with area. We're going to do problem 10.5. And I want you to reach back and remember a few lessons ago when we introduced unit multipliers, how we did it. In 10.5, we're asked to use 2 unit multipliers to convert 44 square inches to square centimeters. Okay, so 44 inches square to centimeters square, right? It's area, so it has to be squared because it's something by something. It's 2 dimensions, so we have a square. So let's get our reference point. We know that 1 inch is equal to 2.54 centimeters, correct? Okay, correct. So now we're going to do the conversion. We put this down here like this. We bring down our 44, and instead of writing inches squared, I'm going to write inches 2 times, and I'll show you why. Inch, inch. Now we make that a fraction. We put it over 1, same as before. And now we're going to put in our conversion. Now, inches in the top here, so we need inches in the bottom so that we can factor them out, right? So we're going to put 2.54 centimeters and 1 inch. Okay. Now I want you to notice something. We have an inch that cancels and an inch that cancels. All right, so that's a pair. We need another pair. We need another inch. So let's put in another one. 2.54 centimeters over 1 inch. So we have this one can cancel this one. Now we can do the math, and everything is over 1, so we're not going to have a fraction at the end. So we would have 44 times 2.54 times 2.54, and that would be centimeters. And we have 1, 2 units of centimeters, so that's going to be your 2 over here. See how that works? Now you could write this a different way. You could say 44 times 2.54, and there's 1, 2 of them, centimeter square. That's an accurate answer. Or you could pull up your calculator, and as soon as it comes up, we'll do the math. There we go. And we could say let me start with the first number, 44 times 2.54 times 2.54, that's the second one, equals, well, that's a big number. I'm going to round it to the second decimal. I'm just going to do 2 decimals on my answers. So 283.87. So 283.87, and the centimeters remain squared because it is area. So either one of these would be an acceptable answer on Jupiter Ed. Okay? But you see how we did that. The main thing is to see the exponent here is 2 over your inches. So you can write inches twice. And that's going to be your signifier. That's going to be what tells you how many times you need to write this fraction for your ratio so you can convert it. So you have an inch here and you can cancel it out. You need another inch to cancel that out. So now you have a square area. Okay? All right. So let's do 10.6. And I'm going to let you solve that one. So let's clear the page and see if you remember those steps. So 10.6. And we are asked to use 4 unit multipliers to convert 125 centimeters squared to feet squared. Okay, so we know we can't go straight from centimeters to feet, so I'm going to give you a little bit of help to start you off. We know that there's 2.54 centimeters for every 1 inch. And we know that there are 12 inches for every 1 foot. All right, that's all I'm going to give you. Work the problem, pause the video, work the problem, and then after you've worked it, press play and check and see if you got the same answer that I did. Okay, and we'll walk through the steps to see where you messed up so you can learn. If you made a mistake, you can learn more from seeing where you messed up because you'll remember that next time than if you just watch the video and try to remember how to do it or go from your notes alone. Sometimes making the mistake actually teaches you more than just watching the video. Okay, so let's try that. Pause the video, and then when you're done solving it, press play. All right, and now through the magic of video, we already have this problem solved. So you can see what I did. I wrote 125, and I wrote centimeter squared as centimeter. There's 2 centimeters because of the exponent 2 here, that number 2. So 125 centimeter over 1. And then I had to go from centimeters to inches in order to go to feet. So we did 125 centimeters times 1 inch over 2.54 centimeters. So that one canceled. Then I did it again, 1 inch over 2.54 centimeters. So that centimeter canceled. Then I had to go to feet. So 1 inch over times 1 foot over 12. So that inch canceled. And I had to do it again. And then that inch canceled. So canceling the units of measure helps you to keep up with however many times you need to write it down. So what that left me with was 125 times 1 times 1 times 1 times 1, which we know is 125 on the top. And then I had 2.54 times 2.54 times 12 times 12 on the bottom. And I had 2 feet units of measure. So that's foot squared at the end, which is what we were supposed to go to, centimeter squared to feet squared. And we did that. And so your answer ends up being 125 divided by 2.54 times 2.54 times 12 times 12. Or you could write it as 125 over 2.54 squared times 12 squared, feet squared. This is as far as you really want to go because the answer is going to be a decimal, like a non-repeating, non-terminating decimal. You're not going to get a solution. It's not going to be 5. It's going to be just this big long decimal. So you could solve it, but the answer that I'm going to be looking for when you have 4 things across the bottom and it's starting to get crazy big or crazy tiny in the case of the decimal, just stop here, okay? I will put the decimal in there, which in this case would be rounded to 0.14 feet square, and that would be 0.14 feet square. You always put the 0 in front. I'll put that in there, but technically that's just really not close. The answer is more like 0.1345018, something along those lines. And that's not exact. But, if it's close, if it rounds up to this, then, or whatever the decimal, whatever this calculation is, and you just have to do the calculation and you put this in, you're taking a risk. You know that this is accurate. You know that this is right. And if you get to this point, then I know you understand what you're doing. So this is unnecessary. You can stop right here. Okay? That's all I have for lesson 10. I'll see you in lesson 11.